This is section 8.2, part 3, talking about special right triangles. And we're just going to simply go through examples. We've talked a lot about the formulas and all that stuff, so we're just going to simply go through examples here. So the very first example says, finding the length of a leg, what is the value of x? And you'll notice in this example that you have a 45, 45, 90 degree triangle. So we also know that we're trying to find the length of a leg. We know the hypotenuse. So formula I'm going to look at here on our thing is that the leg equals the hypotenuse divided by the square root of 2. Okay, so when I use that formula, all I'm going to do now is substitute in. So when I substitute in here, I've got the leg, which is x, equals the hypotenuse, which is 6, divided by the square root of 2. Well, if you remember right, you can't have a square root in the denominator. So what I'm going to do is I'm going to multiply the top and bottom by square root 2 over square root 2. So now on the top, I multiply the tops together. 6 times square root of 2 is 6 square root 2. Square root 2 times square root 2 is the square root of 4, which in this case is 6 square root 2 over square root of 4 is 2. And now since both the 6 and the 2 here are outside of the root, I can go ahead and cancel these. 2 goes into 6 3 times. So this is really just 3 times the square root of 2. That's the length of the leg. Okay. Let's take a look here at the second example. Now, what I want you to do on this one, and matter of fact, for all of these, what I would really like you to do is go through and see if you can solve them before I go through them on the video, and then come back and use the video to check your answers. Okay, because we've been through enough examples now, you should be able to be getting close to figuring out how to do this. Okay, so take the time, hit pause, come back and look through these. Okay, now if you hit pause, you've come back, should have these done. As we go through and we look, let's take a look. We have a 30, 60, 90 triangle. So what I want to do first is I want to identify what each side is. This side over here, this is the long leg, which means this is the short leg, and that's the hypotenuse. Okay, so using my formulas, the hypotenuse is equal to 2 times the short leg, and the long leg is equal to square root 3 times the short leg. All right, so I'm going to go ahead and plug these in. I know that the hypotenuse here is y equals 2 times the short leg happens to be x. So right now I can't solve that equation yet. So I'm going to go down to the second one. The long leg here is 8 equals the square root of 3 times the short leg is x. And I only have one variable, so I can solve. Now, in order to solve, I'm going to have to divide by square root 3. These square root 3's cancel, so x is going to equal 8 over the square root of 3. And again, like the previous problem, I can't leave a square root in the denominator. So I'm going to multiply by square root 3 over root 3. And I end up getting 8 times the square root of 3 over the square root of 9, which then simplifies to 8 times the square root of 3 over square root of 9 is 3. Now, as you look at these numbers, okay, is there a number that goes into 3 and 8? No, there's not. So simply this right here is my answer for x. X, or the short leg, happens to be 8 square root of 3 times divided by 3. So I need to now plug this in up here. So y, which is the hypotenuse, is equal to 2 over 1 times 8 square root 3 over 3. Well, 2 times 8 square root 3 is 16 square root 3 over 3. And that's how much the short leg is. Or sorry, the hypotenuse is. This is the hypotenuse, y, and x, which is the short leg, is 8 times the square root of 3 over 3. Okay, so it kind of gives you an example of what to look at and expect in that example. Okay, now let's take a look at some real life examples now here. It says in the following problem, it says a high school softball diamond is a square. The distance from the base to base is 60 feet. So as you see here, from base to base, it's 60 feet. To the nearest foot, how far does a catcher throw the ball from home plate to second base? So, if it's a square, all of these guys are 60 feet. So now you got to figure out what kind of triangle are you dealing with. Well, as you look at the two triangles, you notice that the legs are the same. So you're dealing with a 45, 45, 90 triangle. And also a 45, 45, 90 triangle. So now you can figure out how much the diagonal is. Okay, the diagonal happens to be the hypotenuse. So the hypotenuse is equal to the square root of 2 times the leg. So the hypotenuse is d, we don't know that, equals the square root of 2 times the leg is 60. So d equals 60 times the square root of 2. Now, the one thing that's different about this one is the directions. It says to the nearest foot, how far does a catcher throw the ball from home to second base? Well, as you look at this, if you type 60 times the square root of 2 in your calculator, you would get this number, 84.853, blah, blah, blah. And if I want to round that to the nearest foot, that means I'm going to make this is approximately, okay, it's approximately 85 feet. I would have to round that up because this 8 is bigger than 5. So it's about 85 feet from home plate to second base. Okay. Again, the key is to notice that the sides are the same. So it is a 45, 45, 90 triangle. All right, let's take a look here. An artisan makes pendants in the shape of equilateral triangles. The height of each pendant is 18 millimeters. What is the length S of each side of the pendant to the nearest tenth of a millimeter? Again, you're going to be rounding this one, so you're going to put this one in decimal form. Now, you'll notice it says it's an equilateral triangle. So, in this case, each whole angle is 60 degrees. Well, if you remember from first semester, if I take an angle and I draw a line perpendicular to the other side, that's what we call an altitude. It bisects this angle. So if that angle is there, that means this is 30 and that's 30. So really, you're dealing with 30, 60, 90 triangles. Okay? And as you look at this here, this would be our little cutout. This is 18. We don't know this. And we don't know this. Okay? So we look at this, you have hypotenuse equals 2 times the short leg, and the long leg is square root 3 times short leg. Well, you don't know the hypotenuse. We want to figure out the hypotenuse, but in order to figure out the hypotenuse, we got to figure out the short leg. Okay? So, first thing I'm going to do, the long leg in this case happens to be 18 equals the square root of 3 times the short leg. Well, if I solve this, short leg is going to equal 18 over square root 3. Again, I can't have square root 3 on the denominator, so I multiply by this. And I've got 18 root 3 over the square root of 9, or 18 square root 3 over 3. Well, is there a number that goes into 18 and 3? Sure there is. I can cancel this one out. 3 goes in there once, 3 goes in there 6. So the short leg is 6 times the square root of 3. Now, in order to find the hypotenuse, which is what I need, I'm going to plug this in up here. So the hypotenuse, which is S, equals 2 times 6 square root 3. Well, this is 12 root 3, and I want that to a decimal. So when I take 12 times the square root of 3 on the calculator, you end up with, it says nearest tenth, so you end up with 20.8. And this is my answer. Okay? So you can apply these to real life type situations. All right, this concludes section 8.2 part 3. Don't forget to complete your WSQ when you are finished.